Okay, we stopped here. So what's the difference between a latch and the flip-flop? The difference is this. Here, okay, so this part. So a flip-flop differs from a latch in the manner it changes state. If you notice in the previous timing diagram, the latch changes state when the enable is high or is low. Let me go back to the previous one. So basically, in this one, enable only change here. I mean, Q change here, where enable is high. Sorry, I need to look for this one here. Okay, when enable is high, it changes state. So that's what we call the latch. Latch change state when the enable is active, regardless if it's active high or active low. But the flip-flop, no. We have studied so if you look at the truth table for D flip-flop and D latch, they are identical. The only difference, there's no enable here. Instead, you have
That's really unique, Faye.
clock.
That a mugshot or your version of Picasso?
And the clock, you have either active positive edge trigger, like this. This is called positive edge trigger. And you can see the arrow is going up. Or negative edge trigger, and you see the arrow is going down. Apart from that, this and this are the same. So basically, there's no difference between latch and flip-flop except when the state change. So in a latch, the state change when the enable is active. For a flip-flop, no. Changes occur at the edge of the clock. Okay? If it's positive edge trigger, it changes when the clock changes from low to high. Like this one, it changes when it's the clock going like this. This one is changed when the clock going like this. So only change occur here at the edge of the clock. So this is a comparison between the D flip-flop and so this is the input here for both the flip-flop and the latch, and this is the output for the flip-flop, and this is the output for the latch. Okay. So the difference between them is this is a positive edge trigger, huh? The latch is a positive edge trigger, which means changes occur at the positive edge of the clock. Okay, so here you can see when it goes, the clock goes from down up. Here we look at D. D is going what we call it was 1, so Q flip-flop will follow it, and no changes here. So this one still 1, it remain. Only here it is, here you can see at this part D is 0, so Q it follow after the clock. Okay, what's important is here, this part. Let me clear it. Okay, let's look at this part here. Look at the difference here. Here, D, we look at exactly for the flip-flop, we look here. D is 1, so Q will follow at 1. Okay? But for the latch, the changes only occur the latch, it only takes this part. Okay, when it's 1 here, it become 1 again, like, but then it changed to 0, and this one changed to 0, while this one did not change because it will wait until the next clock here. It will only check the value at the clock. It does not check the value in between. This one, no, it will check as long as the clock is 1. So this one here, as long as 1, it will affect this. However, for this one, only at the edge. You understand the difference between a flip-flop and the latch? And that's actually summarize it for you, huh? The behavior of the latch and the flip-flop is the same, unless the input change while the clock is high, which is in this case. The clock is high and the input change from 1 to 0. That's why you can see the difference. Okay, and the same here. Any question? No? So we study so far 2 flip-flop. One is the RS and the other one is the D, as well as you have D latch and RS latch. The next one is called the JK, and this is, we call the universal flip-flop because it is very versatile. It can operate as RS flip-flop, D flip-flop, and T flip-flop. So this one can be used to replace any other flip-flop. So the JK, it have 2 input called J and K, And because it's a flip-flop, it have a clock, and the output still only Q, and this is the command, or actually the state. So it looked like RS flip-flop. Actually, you can see, or you can imagine the J is the S and K is the R. So you can see when it's 0-0 is no change or hold. 0-1 is a reset. 1-0 is set. The only difference is here. And for the SR flip-flop, it used to be called do not use, okay, or invalid. Here is different. It's called toggle. Toggle, what does it mean? You can see Q is Q bar, okay, and the Q bar become Q. So toggle means become like an inverter. So if it was 0, become 1. If it was 1, it becomes 0. So that's the only difference between SR and JK. Huh? This is the only difference. This is the only difference between SR and JK. And here you can see is active high, but you can have positive edge triggered, but you can buy them positive edge triggered as well as negative edge triggered, both available. Huh? This is the characteristic equation for it. So again, the difference is only here. There used to be question mark for the RS. Now we put it as toggle. So you can see if QT is 0, it becomes 1. If it was 1, it becomes 0. The rest are the same. This is hold, and this is reset, set, and then this one is toggle. So based on this truth table, I can use K-map, put this one here, and I will get this equation. I have two groups, this one and this one. So the characteristic equation is, you can write it, this one, if you don't want to have this, you can write Q plus equal, okay, K bar Q plus JQ. And this is the timing diagram. It's very important here. If you look here, there is no bubble, so it means it's positive edge triggered. It means changes will occur only here, as well as here, here, and here. So only these places where the changes occur. So only here I need to check J 0, sorry, J is 1, K is 0. So you get, here you have 1, and here you have 0. So it's set, and therefore Q should go up. Okay? It will remain up until the next clock here. And then here I look at J and K. 1 1 1 1 is toggle, so it was 1, it go to 0, and it will remain until here. Here I have 1 0, so it is set. It will go up and it go up till here. Here 0 0, it is hold, so it was 1, it remained 1. And now I can play it for you. And you can see what I have drawn is exactly the output. Okay? So that's how we draw a timing diagram for a flip-flop. If it's positive edge triggered or negative edge triggered. If it's negative edge triggered, then you have to check on the negative edge of the clock. Any question?
No, sir.
No?
No, sir.
Okay. Now, most of JK flip-flop, sometimes they have additional input called the preset and the clear. This are called asynchronous. Asynchronous, which is here, it means they are not affected by the clock. Okay, means the clock have no effect. The clock have no effect on these two. The clock only affect J and K. So J and K are called synchronous input, which means they depend on the clock, and the preset and the clear, they are asynchronous. So if you have preset and the clear, the JK flip-flop can work like an RS latch. Not a flip-flop, but an RS latch, huh? So this is the timing diagram. Notice the preset and the clear, they have bubble, and therefore they are active low. Means they are active when they are 0. So they are active when they are 0, it means this part, the preset is active, and this here, the clear is active. Okay, so they will affect Q. The rest, only this place will be affected by preset and the clear. The rest depend on the clock. So the first clock is here. I look at J is 1, K is 0, so it is set. So it goes 1 until here. Here, what do we have? You have 1 1, which is toggle, so it goes from 1 back to 0. Only up till here. Okay, because here, this part, it depends on the preset. Preset is active, therefore it will go to 1. Okay, now it will remain. After that, it become inactive, so it will remain after here. Here we look at what you have. You have J1, K0. It is set. So it was 1, it will remain 1 until the next clock. Here you have 0, 1. 0, 1 is reset. It will go to 0. And remain until here. Here you have 1, 1, which is toggle. It was 0, it will go to 1. Okay, here is clear. It will go to 0. Okay, and then here will affect by, here it affects by JK, J0, K0, so hold, it was 0, it remains 0. So that's how your timing diagram look like. If I play it. Okay, you can see it's exactly like what I have drawn. I can remove my it's clear how we do timing diagram. Any question? No? You can make a T flip-flop from what we call D flip-flop by using this feedback. And you can make T flip-flop also from JK flip-flop, or you can buy a T flip-flop. The symbol for it is like this. This is the truth table, the characteristic table. You can make it out of JK flip-flop, and this is the K-map, and you can see you have two ones here and one here. You cannot combine them. So this is the characteristic equation, and this is the timing diagram. And what's important is that only when T is 1, okay, the output will toggle at the clock edge. So you can see here this negative edge trigger, so it occurs here at the negative edge of the clock. So it was 0, become 1, and the next clock, which is here, it was 1, become 0. So it just toggle only when T is 1. When T is 0, the output always 0. So when T is 0, which is here, you can see Q plus equal Q, which is hold, which is this one, hold, toggle. So it only have two states, either hold or toggle. And this is the state diagram for JK, for D, and for T. The RS I have given to you earlier. And this is the excitation table. I have given you the one for the RS. This is for D, which is very simple. Okay. You can see here, if 0 and remain 0, D is 0, if 0, change to 1, D is 1, 1, 0. So basically, these two are the same. Okay. And this one you can see here, if 0, 0, it means T is 0, which is hold. Okay. 1, 1, also T is 0. So this is part all hold. This is from hold. 1, 0, 1, 1, 0. T is 1, which is basically this is one, the toggle. This one you can get it from my truth table, the truth table. 0, 0, 0, 0, it means either hold. So if Q 0 and Q bar 0, it means hold, which hold means J 0 and K 0, and that's why. Or it's possible that which one you get? 0, 0. Reset. Reset means what? J 0 K 1, and that's why you can see K change, so it becomes don't care, and J both is 0. That's why you get this. So this is the excitation table, which is very important for you to remember. I don't memorize them, by the way. What I remember, I tell you which one I remember. So
Hey guys.
for JK flip-flop, I remember this. So I remember the characteristic table. This table, I remember it for all the 4 flip-flop, because very easy to remember, and from it you can obtain everything else. I can obtain from it the characteristic equation. I can obtain from it the excitation table. Any question? We have studied this one before for the logic gate, but we have the same thing for the flip-flop, which we call propagation delay. And propagation delay is measured here between the clock and the output. Okay. This is for positive edge trigger, this one for I mean, this one from, sorry, low to high, and this one from high to low. Okay, this is for synchronous input like JK or D, and this one for asynchronous like preset and declare. Setup and hold time are important. Sometimes your circuit doesn't work because of this, which means setup time is this the time from here to here. So basically, before the clock change, the input must be hold, which means should not change. Okay, which means this time here, your input should not change. If the input change, the output is not predictable. And hold time is here, which means the time where the input remain stable after the clock. So basically, for flip-flop to operate properly, the input should not change from here to here. Should remain constant. Okay. Other specification: maximum clock frequency or minimum pulse width are actually maximum clock frequency, minimum pulse width, very similar, because this one tell you how fast this maximum clock frequency depend on the TPLH and TPHL. So these are the technical specification which is required for your flip-flop to operate correctly. This is only important if you are actually building project using flip-flop, not in the theory or in the design, only when you are building the actual circuit. Okay. Any question?
No, sir. Still processing.